Hello. Today we'll be talking about simplifying rational expressions and their basic operations. So, a rational expression is any fraction whose numerator and denominator are both polynomials. And some of the fundamental properties I want to talk about are factoring, right? So it would be something like 3x squared over 4x. What we can do is we can say, well, I see an x in both, so I'll see at least one x in both, so I can factor. And what that allows me to do then is cancel, so that I'll just get 3x over 4. Right? I can multiply two expressions together, right? And unlike adding, when I multiply, I can just multiply straight across. So if it's a over b times c over d, I will just get ac over bd. Division's very similar. However, we can't really divide fractions. So if we're ever asked to divide fractions, what we really have to do is multiply by its reciprocal, right? By the second fraction's reciprocal. So if a over b is being divided by c over d, what I have to do is I transform this into a multiplication problem. I have to make this a over b times d over c. And if we want to add or subtract, what we'll need is common denominators, right? And we'll go over some ways to do some things like that. So very quickly, we can look at this and say, okay, can I factor things out? Well, yes, I can factor a 2x squared out of the numerator. And if I factor that, I'm just left with 1. I can also factor a 2x squared out of the denominator. And if I take a 2 out of the 8, I'll have 4. If I take x squared out of x to the 6th, I'll have x to the 4th. Those 2x squareds will cancel, and I'll just be left with 1 over 4x to the 4th. Right? If I look at the second expression, I can just multiply straight across and get negative 52m squared over 18n cubed, and then worry about canceling, right? But that seems a little too difficult. What I can do is I can take a cue from the top and look at simplifying first, right? So instead of going through and saying, how can I simplify 52 and 18, right? If we just undo that a little bit, what I'll do is I'll look at this expression right here, and I'll say, can I simplify things first? Can a numerator cancel with a denominator? So of course I see a 3 and a 9, and a 2 and a negative 14, which reduces like so. So now when I multiply straight across, I'll get negative 7m squared over 3n cubed. And that's a much simpler expression to deal with. Right? I've done my factoring first, and it's helped me get a much easier solution. We can take that same idea and work on it here. Right? This way I'm dividing. And so just like what we said, if I'm dividing, I really have to change my division to a multiplication problem, and I want the reciprocal of my second fraction. Right? So although the way it looked here made it seem like we might be able to cancel things, right? We might be able to cancel some of these x's or some of these y's. When I change it to the appropriate type problem, I can see there's no way, if I look here at my x's and the y's, I can't cancel. And if I look at the y's and the x's here, I can't cancel either. So I'm just stuck multiplying straight across. And of course, when we multiply, we need these parentheses because we're multiplying entire quantities, right? I'm not multiplying just one y, or I'm not multiplying just one negative 1. I'm multiplying an entire quantity y minus 1, right? And because we can't cancel, we can just leave it like this. Right? Let's look at some more, right? And so here we want to try and see what can we factor out of this fraction, right? So I'll look and I'll say, well, out of the top, I can take a 2. I see a 2 repeated. I see an m squared and an n. the first. So the only thing I'm allowed to take out is this m to the first. And likewise, I have an n. Sorry, let me take some of the stuff out. I have one n and an n squared. So the only thing I can take out is one n. Let's say if I take all that out, a 2, an m, and an n, what do I have left here? Well, I just have one m. And if I take all of that stuff out here, I'm left with one n. And I can't touch the bottom, right? That's about as simple as I can get it. But I notice here that I can just cancel out, and my final answer is just m minus n. Right? I'll move on to my last example here, and I'll say, well, I could just multiply straight across, multiply these giant quantities, but that would be kind of, I'd really be missing an opportunity to factor. So let me try and factor first. Right? I'll look at factoring this first expression, and I get x minus 6, x plus 1. If I look to factor the denominator, that's just the difference of squares, so it's x minus 1, x plus 1. If I look to factor that numerator on the second piece, that's just x plus 1 times x plus 1, right? That's one of those perfect squares. And again, we have a difference of squares, x minus 6, x plus 6 for the second one. And so instead of, again, multiplying straight across, all right, I don't want to do that. I want to say, well, what can I actually cancel? Right? I see an x minus 6 will cancel, an x minus 1 will cancel, and that's it for right now. Right? That's all that I see that cancels. So I have an x plus 1, x plus 1 over x minus 1, and x plus 6, right? And again, that's as simple as I can get it. We can just leave it like that, and that'll be fine. And so if we want to add or subtract, what we're going to need to do is find a least common denominator, and these are the steps. We want to factor each denominator, right? We've done work with factoring before. We want to identify unique prime factors. So let's say for something like 18, we want to break that up. We'd say it's 9 times 2. But because we want prime factors, I'll say I want to break that up into 3 times 3 times 2. And because we want unique, all I'm going to do is take one of the 3's and the 2. Those are the unique prime factors. And I'm going to form a product using each unique to the highest power. Right? So if we take that 18 example before, we had 3 times 3 times 2. That's 3 squared times 2. These are unique to the highest power. So let's look to simplify this expression. So I want to factor each denominator. So for 10, I get a 5 times a 2. For this middle number, this middle expression, I get an x minus 1 and an x minus 1. And for this last expression, it's as factored as it can go. So what I want to do is I want to say, we can think of this middle one as an x minus 1 squared. So the least common denominator will have the unique factors, right? That's the key. We want the unique factors. So we have a 5, a 2, and an x minus 1, but it needs to be squared because we want unique and highest exponent. Right? 5 times 2, x minus 1 squared. That is our common denominator. Right? Times 2, x minus 1 squared. 5, 2, x minus 1 squared. Right? And so when I want to actually start to express this, I look at this first thing and say, what's missing from this denominator that is in my common one? And I can see that this x minus 1 quantity squared is missing from this original denominator. So I have to multiply my original numerator by that. Right? I look at the second denominator and say, well, that 5 times 2 is missing. So that's what I should multiply that x plus 2 by. Likewise, what's missing from the third denominator? I only have 1x minus 1. I need a 5, a 2, and an x minus 1. So let's bring some of the stuff up so we have some more room. So here's our last line, and we'll still work to simplify it. So now that everything has a common denominator, we can actually bring it all under one kind of large denominator. And then work on simplifying this numerator. 3x minus 1 squared plus 5 times 2, x plus 2, minus 2x times 5 times 2, x minus 1. And we can work on simplifying each of these first, right? That's separated by the plus or the minus. And what might actually be better is if we work with more colors, so we can see how things will simplify. So I want to FOIL this x minus 1 squared. I'll get x squared minus 2x plus 1. Right here, I get 10x plus 2 minus 2x times 10x minus 1. Right? And it's still all over my same denominator. We'll make that 10. Right? We'll make that 10x minus 1 squared. And we'll work on simplifying it one more time. So I'll distribute that 3 up top, 3x squared minus 6x plus 3. Now 10x plus 20. Here, so we don't simplify too many. This negative 2x times 10 is going to be negative 20x. So I'll get negative 20x squared plus 20x. So I'm distributing negative 20x by a negative 1, so that's a positive, all over 10x minus 1 squared. And let's see, I'm still running out of space, so let's see. Look at the squared terms. Here's the squared, here's the squared. I get negative 17x squared. Here's the x, and an x, plus 24x, a 3, and a 20, plus 23, all over 10x minus 1 squared. So these problems can get fairly involved depending on the complexity of the denominators. This happened to be one of the more difficult ones because of how complex the denominators could be. But now let's work on dealing with something a little bit different. We want to try and simplify something where we have fractions are within fractions, right? We call them compound fractions. And the whole goal is we just want one fraction bar. And so what we're going to do is we're going to have to simplify this. So how do we simplify this? We do that LCM, that least common multiple, least common denominator, twice. We have to do one for the numerator, find one for the denominator, and then take the biggest one and find that. So here's what we'll do. We'll look at this numerator, 1 plus 2 over x. We're just going to work with the numerator first. So if I was going to get a common denominator, what would I need? Right? Anytime I see 1, I can think about it as 1 over 1. And I have 2 over x. So 1 and x gives me a least common multiple of just x. Likewise, I have 1. I look at my denominator. I have 1 and x squared for my denominators. So my LCM is going to be x squared. And so I look to find an LCM of LCMs. Sorry, that looks like a cube. I look at x to the highest power there, so that's x squared. So what I'm going to do, I'm going to take my original expression and multiply by x squared over 1 divided by x squared over 1. Again, if I want to multiply anything, I need to multiply that quantity by the numerator and the denominator. And so I'll look and I'll distribute. X squared times 1 is just x squared. X squared with an x in the denominator, one of those x's will cancel, and I'll just get 2x. Likewise here, I'll distribute that x squared over 1 here, x squared minus 4. Those x squareds will cancel. And I'll say, can this simplify any more? Can I factor things out? Well, yes, I can take an x out of the numerator. I'll be left with x plus 2. That denominator is, again, a difference of squares. So it's x minus 2, x plus 2. Right? I can cancel the x plus 2 terms, and I'm just left with x over x minus 2. That is my final answer. Thank you for listening to this video, and I'll see you in class.